Hi all, welcome to the webinar hosted by Numerical Analytics. So today we have Mr. Jalaj with us. We will be looking at the calculus. So the topic of today is infinitely small, make it visible with calculus. And we will be digging deeper into calculus through IB diploma question, which ends by 6.2. So I welcome Mr. Jalaj, all the participants and the panelists. Welcome.
Thank you, Hassan. It's always pleasure being here, being numerical analytics. So, what are we doing today? Exactly.
Oh, Jalaj, exactly. We are doing some kind of calculus today. But before going to start with the topic and before doing all the questions regarding the calculus, I just want to know from you what is calculus and why do we study it?
Calculus. Okay, this is a very interesting question. And when it comes to calculus, everyone thinks that calculus is something that is used in engineering. This is something really high-tech thing, and something which engineers use, and those who do sophisticated calculations they use. But calculus is basically it is just like measuring your height or weighing yourself. So, as we all know that geometry is the study of shapes, algebra is the study of generalization of arithmetic operations. Similar to that, calculus is basically a mathematical study of continuous change. Wherever you see a change, calculus is there. So the study of calculus is normally aimed at giving you the mathematical sophistication to relate to more advanced areas of mathematical studies. So when you do your further studies, it gives you a
Rakesh, दरवाजा बंद कर देना.
very strong base. And calculus, basically, to summarize, if we say, uh, pebbles. The Latin form of word calculus actually means pebbles. Yes, John, thanks. Thanks for contribution. So calculus is basically study of how things change. So it provides a framework for modeling systems in which there is a change and a way to deduce the prediction of such models. For example, change in position. As like there's a very famous saying, change is the only constant. Change always happens. So when position of an object changes, we call that object has been displaced. Now, calculus can provide us a way to us. To construct a simple quantitative model of this change and to deduce their consequences. We can also investigate the effect of the change in the parameters of the model. Like when we are talking about the displacement, if time changes, how displacement is changing. Moving further, when it comes to velocity or acceleration, then we can create models and we can investigate the change in parameters. So basically, broadly, if we see in calculus, we study calculus in two different ways. First way is when we study instantaneous change of a function. And remember, function is nothing but the model of any real life situation. So the study of instantaneous change in a function, and we call it differentiation. And another one is going back from derivative of a function or differentiation of a function back to the function, and that is called integration. And as it sounds, integration is basically putting things together, putting it together. So like you all are mathematicians, so we can connect integration with the summation notation for the discrete variables.
Yeah,
So
Jalaj, there is a common thought that the calculus is required at an engineering level. Then why calculus is taught at IB DP level? Like this is my one concern. Like it's a common thought. Like engineers use calculus more, but why do we taught calculus at IBDP level?
mhm. Okay, again, very good question. Like, as I said before, people have this perception that calculus is something which is useful only at engineering level. Yes, it is highly effective at that level, at that sophisticated level. But there is always a first step before you reach anywhere. So before we move on to that, let's check first what are the areas where we use calculus. We all have credit cards or debit cards. Like recently I got huge credit card bill and I was thinking how to pay it in installment without paying any penalty or paying any interest rate. Credit card companies, they use calculus to set the minimum payment due on a credit card. And the variables which they consider are changing interest rates and fluctuating available balance. So when we get a credit card, all the calculations are done with the help of calculus. Biologists, they use a differential calculus to determine the exact rate of growth in a bacterial culture when different variables such as temperature and food sources are changed. Now, this research can help us increase the rate of growth of necessary bacteria or say good bacteria, and we can decrease the rate of growth. Again, when I say rate and growth, so we are talking about the change, hence there is calculus. And we can decrease the rate of growth for harmful or potentially threatening bacteria. So biologists also use it heavily. Then like electrical engineer, they like engineers, they use, like for example, to integrate this integration to determine the exact length of power cable needed to connect two substations that are miles apart. A physicist uses calculus to find the center of mass of a sports utility vehicle to design appropriate safety features. Then in statistics, we use so much of calculus. We have been seeing it in like different webinars, and practically in statistics, we use calculus to evaluate survey data, to help develop business plans, different company strategies and surveys using different questions. And so we can use make good use of calculus there also, and so on forth, so on so forth. So now to use calculus effectively, one need to start somewhere so that they can practice and they can make foundation. Hence we study calculus in IB diploma. In fact, we
So yeah.
start, sorry, in fact, we start with calculus long back. If we see trigonometry is considered part of calculus. So that is the actually, like in my opinion, that is why we study calculus extensively in IB diploma.
Oh, great point, Jalaj. So engineering is not the only field where we require calculus. There are many other fields, and the use of calculus is infinite.
Exactly,
So
exactly.
a
There are
good point to
numerous.
tell students, I think.
Mhm.
So, Jalad, what is the weightage of calculus in IBDP? If I want to know, like weightage in comparison to different subjects, like
Okay,
calculus.
okay. Great question again. Where did you get all these questions from, Hassan?
I just came in my mind, like I should ask you before going to start with the session.
Okay, so see, calculus has always been a very important part of all mathematics courses. Now, after this, from class of 2021, this new mathematics, uh, calculus has been distributed differently for different like courses. For example, if when it comes to analysis higher level or standard level, it ranges from 28 hours up to 55 hours, and in applications it ranges from 19 hours to 41 hours. Okay, to make it more friendly, you'll be surprised to see this data that in IBDP mathematics, in May 21 examination, in MAA, directly or indirectly, approximately 39%, 39% of the paper was based upon calculus. And you find calculus in all the papers, whichever the paper, whichever the course you do, whether you're doing, like if you do AP stats, you may not find that much of calculus there. Otherwise, anywhere, wherever you go, you will find calculus. And like my experience as an IB moderator, I've been moderating internal assessments. So my experience is, and I'm sure everyone will second me, After stats and probability, the next most popular topic for mathematical exploration is calculus. So this tells like how important calculus is and why should we really take this very seriously, not only for examination purpose, but only for the also for the learning purpose also. So without
So
what do you
yeah,
think, Hassan? Should we start?
yeah, we should start. I think my questions has been answered by you, so thank you so
Great.
much. So
So
now we can
I
start with
hope
the
I
session.
answered
Yeah.
all your questions
So
and
if
participate.
anybody participant has any point to raise, I think there are some points that participants has raised. So we can check, like, John has raised some point, a good points. Thank you.
Mhm.
Yeah. So I think we should be starting with the session. So
Okay, great. So so let's start with this beautiful and important calculus webinar. So Hassan, would you like to start today's session? Are we solving some questions or how are we doing it?
So what we will do, we will share the questions with the
Yes.
participants in the
Please
chat
share
first,
those questions with the
so that they can be able to
participants.
see, and then we can start. So I'm
Love it.
sharing the
That,
questions
that'll
with the
be great.
participant in the chat. So these are the questions we will be discussing today. So you can have a look. And in this, I would like to start with the first question. That is a question from the probability distribution. All right. So let me just share my screen, and yeah, here. So this is the probability distribution question, where the continuous random variable x has
Mhm.
probability density function is given here. So Jalaj, would you like to just elaborate about the question?
Oh, sure, sure. Let's read it together. The continuous random variable capital X has probability density function f given by this function. So if you look at this function, this is defined between 0 to 2 only, and after 2 it is 0. So when your random variable takes values between 0 and 0.5, the probability is given by 3ax, which is a linear function with positive gradient. And from 0.5 to 2, again, it's a linear function with negative gradient. So probably you will get like a sort of graph when you draw this. Now, this is a very special function because this hybrid function is not simply a function. It is a probability density function. And probability density function means it represents all possible probabilities for a particular experiment. So the area under the curve for this function will be total probability, that is 1. So so best way to approach in my opinion is we just find the area under the
Yeah,
curve
I
and we
think
put it equal to 0. And
so.
one more thing here,
Mhm.
did you see we have one unknown involved in
Yeah, A is
mathematics?
unknown. Yeah,
Whenever there is any unknown to be found, we have to make an equation.
equation, correct.
To make that equation, how do we make the equation? Just use the information given and use those hints and clues to form an equation. So here we can see we need to do, I think, area under the curve. So Hassan, all yours, I think.
Yeah, so to find the value of A, I think the total probability should be equals to 1. And rightly said by Jalaj that the area under the graph should be equals to 1 for the total probability. So what we'll do, we'll create an equation to find the value of A, where we will be doing, like, we will be taking the area under the both graph, and we'll say like that's equals to 1, and we'll get the answer. So let me just share my screen of the emulator. So on the left side, I have my question so that you can see what the question says and the parts of the question. And on the right side, I have the solution. So this is the very easy way of doing. Like generally we do like this only. We solve the question by taking the creating an equation. On the left hand side, we'll take the area under the graph from 0 to 0.5, because it's a hybrid function. So we will take from 0 to 0.5 the integration. We'll take the area of 3x, and we'll add that area to 0.05 to 2, that is 2 minus x times a. and we'll say like this is equals to 1. So total probability should be equals to 1, and we will be able to find the value of a. So because the variable is a, so we'll put it inside and solve, and we'll get the solution here, which is nothing but 0.666, and it goes on, that is 2 over 3.
Yes,
But
2 3 years.
Jalaj, there is another way of doing this. See, here what we did is we wrote whole hybrid function again and again. Like we have given like 0 to 0.5, and then again we have to write from 0.5 to 2. But there is another way of doing this question. Like if we store this function,
Oh
if we
yes, yes,
store this
we can
function as
define it.
fx, in one line we can do this. In one shot, we can do this by creating only one integration from 0 to 2. So let me just show you what I can do here. So let me add another calculator page, or what I will do, I'll store this function. So I won't take much time in writing this, because we all know how to store a function. Okay. So I'll copy this and paste this. So I'll say this is my hybrid function of probability density, and I'll store this as f of x. I'll hit enter and the function has been stored. And you can see for else values, it gives you like 0 for else. Okay, so it indicates like for any other value, the function is 0. So now here what I can do, I can now create an equation. The equation would be integral from 0 to 2. Now I can say, okay, f of x. So now the whole lot of equation that was very clumsy, now compressed to a very small equation, that is nothing but 0 to 2 fx dx. Now I can put like this should be equals to 1. Oh, I'm sorry. This should be equals to 1. And I'll put this inside and solve. Okay. I'll put everything inside and solve. So I can go to algebra and I'll put everything inside the and solve. And I say, okay, the variable is a. Hit enter, you get the same result. So, is there any question? Yeah, yeah, Shada ma'am. So what I did is I created a small equation, because I have already stored a function fx that was a hybrid function, and I created equation from 0 to 2 fx dx equals to 1, and variable was a, and I get the same result. Now I can change this value to fraction by going to number approximate to fraction and get the result like 2 by 3. So you don't have to write everything. You can just store the function and you can get the result. So first question has been answered, like a is equals to 2 over 3. And now, because in the function, the probability density function, a is a variable. Okay, still I haven't defined a anywhere. So I can go back and I can define a as 2 by 3. So now
Mhm.
in other parts, so now in other parts, a will come as 2 by 3 automatically. We don't have to do anything. So we don't have to even write 2 by 3 as a, because we have already defined it. So now a is 2 by 3. So now for the next part where it says find the probability when your random variable is x then less than 1, what I can,
Hassan, but
yeah,
sorry,
yeah,
there is a question, quick question here from Brijesh. Um, if the question says show that a is equal to 2 by 3, can we use calculator and say it is 2 by 3, or should we manually integrate and show? You may not manually integrate this, but in your answer space, you must write that by using the integration. Show the integration sign, and you don't have to show the steps, but examiner should get an evidence that you have used integration for that, and that will be great. And next thing is like Hassan defined it 2 upon 3. So once you define it, you don't need to go back and change your function, replace a by 2 by 3. When once you're defined, it's done. Yeah, Hassan, sorry to interrupt you.
no,
Please.
no issues. So for the next part where we need to find the probability when your random variable is x less than 1, what we can do, one way of doing this is we can write the value of a like 2 by 3, and we'll use again step integration like 0 to 0.5 and then 0.5 to 1, and we write the function separately and we get the result. Other way of doing this, other way of doing this is we can just say, okay, I have to integrate from 0 to 1. Now f of x, I need to integrate with respect to x. So now I have defined the function. Even I have defined the variable a, which was unknown in the function, as Jalas indicated. So now in just one step, if I click enter, I get the result. So this is how you can avoid writing the whole set of equations. Okay. So it will save time. Okay. Because you know the function is defined and you can use the technology to do that. In the third part, and that is more interesting part, where it says given that probability from s to 0.8 is equals to 2 times the probability from 2s to 0.8. And here it says, and that s should be lie between 0.25 to 0.4, find the value of s. Here, one way of doing is writing the whole equation like LHS from S to 0.8, you have to write LHS and then equal to 2 times and then 2s to 0.8. But as you have seen, we have defined the function. We can use that feature of the calculator and we can just say, okay, no issues. We'll just go to algebra and solve. And same equation can be condensed into a smaller one, saying, okay, integrating from s to 0.8 f of x dx. So now when we say s to 0.8, it automatically takes the hybrid function accordingly. And this should be equals to 2 times integration from 2s to 0.8 f of x dx. All right. So equation is completed. Variable is s. Hit enter. You get the result. 0.2741842. And the same result was we were getting from doing the whole lot of equations, clumsy equations, I would say. Like this is a simpler one. So isn't it cool, Jalad? Like we can store
Yes,
function
yes, absolutely. Yeah.
and we can use that function in the end solve and we can solve for the variable. So this was the way of using calculus even in the probability kind of questions uh, and doing certain kind of things. Like we have two methods now of doing the same question. We can even store the function, or if you want to write the whole set of function, you can do that as well. So this was the first question. Now the second question is very interesting and it is related to the implicit functions. Okay, so implicit functions has a very good role in IBDP. So Jalaj will be taking that question for implicit functions. So over
Sure.
to you, Jalaj. Anybody wants to add something here, or is there any question?
Yeah, we have some discussion, interesting discussion here. Like when it says there was a question from Brijesh that when, let me read it out. John Brajesh asked that should we show some working, show that we'll need algebraic method. So my take is this is a 3 marks question. So when we are showing this much of integration, we are showing a good process to earn 3 marks.
So
Where,
I too agree when you are using integration and equating it to one, that itself explains the concept
exactly.
behind it.
Yeah.
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 So when you do that and you equate it to one and you solve for the value of A, when you write that expression, you write the equation. The students, of course, just can't write 2/3 since it's it's a show that question. I think that an equation is very important, which expresses the the solving through integration and equating it to one, solving for A.
I'm not referring to solving for it is an integration question. Definitely. Can you hear me, by the way?
Yeah, yeah, yeah.
Okay. I'm not referring to that. I think I don't know whether I understood Brigish's question, but that just made me think that the show that is of course a different thing from find. Find you can use a calculator, and obviously use. The point is not about using integration. I doubt it. We can use any other method, but the point is a calculator solution enough, or an algebraic method enough? I mean, I'm happy to be wrong. Correct me.
Yeah, John, what I feel is like in this question, in this context, particular context, when if the question says find the value of A or show that A is equal to 2 upon 3, 2 by 3. In this, for this question, I think they both will earn 3 marks if we show the integration. As Shraddha mentioned, we need to mention that total probability under the curve is equal to 1. So with that rationale, we can continue and when we find the value of A, it is like showing that it is 2 by 3 or finding it is the 2 by 3.
Okay.
Yeah.
Okay, so we'll proceed to the next question.
Yeah.
So
Second question.
let me just share the second question and you can read out and then you can share.
Yeah. So the second question is, okay. So consider the curve C defined by the equation y squared minus 2xy is equal to 5 minus e raised to the power of x. The point A lies on C and has coordinates this. Find the value of A, show that this, find the equation of the normal, find the coordinates of the second point at which the normal found in part C intersects C, given that V is decimal, blah, 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 and so on and so forth. Okay, so let me share my screen and let's get going. Okay, so for this question, consider the curve defined by this, find the value of A. So I would like to add notes first. In notes, we can do some working also here. So this question is y squared minus 2xy is equal to 5 minus e raised to the power of x. And point 0 comma a, where a is more than 0, lies on this function. It means when you plug in x is equal to 0 and y is equal to a, this equation must be satisfied. So we can simply write like a squared, or we can just look into this. We get a squared minus 0 is equal to 5 minus 1. That is y squared is equal to 4. So when y squared is equal to 4, y is equal to plus 2 or negative 2. But the question says a is more than 0. So a is equal to plus 2. So a is equal to 2. This is our part A. Hassan, please take care of the chat.
Yeah, Chalaj.
Yeah. Now part B is show that dy by dx is 2y minus e raised to the power of x divided by 2 times y minus x. So again, this is simply implicit differentiation. So y squared will give you 2y dy by dx minus 2 times x dy by dx plus y is equal to 0 minus 5 raised to the power of x. And after simplification, we get part B. So I'm not doing this also. Do I need to do? What do you think, Hassan? Should I? No need, right?
No, you can
Yeah,
skip.
yeah. There's just like manual work, so all our honorable teachers can do. Part C, find the equation of normal to C at the point A. Now, when we find equation of tangent to C at the point A, so to do this, we can draw this implicit function. Now, when we draw this implicit function, we can do this in 2 ways. So let me open a new graph page. In the new graph page, we can change it to relation. So in relation, we can write y squared minus 2xy minus 2xy is equal to 5 minus e raised to the power of x. So is equal to 5 minus e raised to the power of x. We can write this relation, but when you enter, then you will get an error message. Anyone, why do we get error message here? Why can't we draw this relation? Feel free to.
I think because exponential is there.
Exponential is there. So create a slider for xy, no. So what I do first is I will write it 2 times x times y. Yeah. So the following relation input are supported, relation for this, and then polynomial relation in x and y. So you cannot draw this relation. And moreover, if you have relation, Hassan, can we use relation in exam mode? In
No, we can't.
So in press to test, this is disabled. So we cannot use it. So what seems to be required is something which can solve our problem. So let's go back to our first page and have a look at the question once again. The question is y squared. Let me write it down quickly here so that it remains here. Y squared minus 2xy minus 2xy is equal to 5 minus is equal to 5 minus e raised to the power of x. So this is e raised to the power of x. I'm using this notes so that I don't get any error message when I enter. Okay, so this is our equation. We cannot draw this relation, but we need to draw if you want to find equation of normal using the calculator. Manually, you can do it. It will take some time, but it is a paper 2 question. And for this question, you have how many marks? So let me check marks for you. For this question, 3 marks. So equation of finding equation of normal were 3 marks. Doing it manually will take long time. So what can we do is, let's try to identify what is happening here. This one, y squared. Do you see this y? And this y. Is it a quadratic equation in y?
Yeah,
Can we
it
write it?
seems so. It seems, it looks like, because if we take
So can
y
we
as a
write
variable only, yeah.
as plus e raised to the power of x minus 5 is equal to 0?
Yeah, we
So
can.
this is a quadratic equation now. Oops. I made some mistake, but I can always do Control Z and undo this. So what we can do is we can find the value of y and we can define that as 2 functions or just copy and paste there. So what will be the value of y out here if you see? So what you can, there is one more interesting facility here. You can insert a math box here, math box. Now within this box you can perform all sort of calculations. So what I'll do is I will define my function fx as, fx will be my function. I'll define this as, I will use the quadratic formula that negative b plus minus b squared minus 4ac upon 2a, and I will define this out here. Negative, when I'm solving for y, a is 1, b is negative 2x, and c is e raised to the power of x minus 5. So this will be negative b means 2x plus minus. So I'll define one function as plus and another function as minus. So fx is negative b plus square root of b squared. What is b? B is 2x. So it will become 4x squared minus 4ac. So minus 4 times 1 times negative 5 will be plus 20. Hassan, please keep checking my calculations.
Yeah, I think e raised to power x will be there. 5 e raised to power x.
Oh yes, e raised to the power of x. I
Uh,
was thinking something was wrong here. Okay, so b squared minus 4. 4 is here, a is fine, c is e raised to the power of x minus 5. So I'll write e raised to the power of x minus 5. Minus 5 divided by 2a will be 2. And I enter. So my function fx is defined, right? So now what I can do is I can just copy this one. Control C will copy this. And I can write another function here in my maths box. And I can paste this thing. I can make minus. That's all I do. And this I can define as gx. Gx. And this is done. So once we do this much of work, then things have become very easy. So we go back here and we draw it. So relation we don't need now, so we can go back to graph entry as a function. My first function will be fx and I enter. Oops, sorry, this is fx. This is my function, and my another function will be gx. There you go. So this is my function. So the question says, and now since we are discussing this one and we are seeing the feature, so it is taking some time. Otherwise, it takes max 2 or 3 minutes to do this, the entire question. Find the equation of normal at point A. Now, what is point A? Value of A was 2. So point A is 2 comma 0. So if you want, you can move it, or you can just actually delete this. We don't need these ones.
So Jalaj, the coordinate would be 0, comma 2.
Point A, yeah, 0 comma, point A is lies on this 0 comma A, yep, so 0 comma 2. Now 0 comma 2, you can see when x is 0, y is 2, which is here. So you can take point P and you can place anywhere this point. Sorry. Just press P, go to point, and this one you can write 0. So 0 comma 2. So this is your point. So at this point, we have to draw a normal. To draw normal, again, try seeing, do we get anything from the menu? If you go to points and lines, we see that we can draw a tangent, but we cannot draw normal here. So what do? We draw tangent. Where do we draw the tangent? At this point. Now, how will this help us? We will use the basic definition of tangent and normal, that normal is always perpendicular to the tangent, right? So we'll go with, oops, let me move it here. So normal will be a line that is perpendicular to tangent at this point 0 comma 2. So again, let's go and check if we can draw a line which is perpendicular to this. So points and lines, line segment, point, no, we cannot. But if you go to construction, in construction, you have perpendicular lines. So we can, at this point, we can draw a perpendicular line. This one, and this is our perpendicular line here, right? So this is the normal. But if you see, this is a construction, this is not the equation. So we, how do we get line of this? If we select this, do we get its equation, coordinates and equation? So we get the equation here. So this is equation of your normal. So y is equal to
Jalaj,
negative.
can I
Yep.
interrupt?
Yeah, please.
Yeah. The thing is, isn't construction mode disabled in the press to test mode?
Yes, it is disabled. You're right. So what do we do here? So y is equal to negative 0.75 means 3 by 4. So we can quickly do this question. See, we are doing these questions to discuss the concepts in the classroom and from examination
Right.
point.
I got that. I was just confirming if
Yes, absolutely.
Yeah. Thank you.
I overlooked that. So
Yeah,
press to test, it is
Jalaj,
disabled.
I want to add one more point. Like,
Yeah.
yes, it is disabled in press to test mode, but yes, we can draw tangent in press to test mode. And by drawing a tangent, we easily get the slope and the y-intercept. So we know the y-intercept would be same and the slope would be -1 upon the slope of the tangent, and we can get the equation of the normal from there as well.
Lovely. Thank you. Thanks, Shraddha. Thanks, Hassan. Now, moving on. Find the equation of normal. So we got this equation of normal. Part D says, find the coordinates of the second point at which the normal found in part C intersects C. So we are actually looking at this point, the point of intersection, this point of intersection. Now, if you go by a simple analyzing graph, in analysis of the graph, we may not get point of intersection, this point of intersection, because this no intersection found within the specific bounds, because this normal is a construction. This is not a line. So what we can do is we can quickly copy this negative of 1.33x. This is negative 4 upon 3x plus 2. So you can quickly draw this. Y is equal to negative 4 divided by 3 x plus 2. And once you do this, you see it, you get a line right on top of that construction.
Jalaj,
Now,
I think when you did get the, the this was smart drawing the tangent to get the normal, because this is 3/4.
yeah,
So students would know. So I understand what you are trying to do here. Is from 3/4, the students could get negative 4/3, and the point being drawn at the normal being drawn at point P, which is 0,
Mhm.
2. So 2 is definitely going to be the
Right.
Y-intercept.
yeah. So yeah, so I get the purple line and how it can help in an examination
Yeah,
situation.
yeah. So then now we can go to analyze graph, find the intersection. Your graph, your one graph is this, and your second graph is this, left bound, right bound, and you get your point of intersection here. So this is your point of intersection. And in okay, any questions so far? Any discussion? Anything that you agree with, disagree with? Please feel free to discuss.
Jalaj, I may have missed something. How did we get the red and the black parts to it? Is it so?
Okay, so what we did is we formed a quadratic equation out of this
Yeah.
by, then we took both parts. Then you have positive of discriminant square
Oh,
root
okay.
and
Got
negative,
it.
and I
Got it.
drew both.
I got it now. Thank
Yeah.
you.
So here we get, okay, moving on. Next is given that v is equal to y cube and y is more than 0, find dv upon dx at x is equal to 0. So this is again a simple like rate of change thing. So we have to find the rate of change of v with respect to x. So dv upon dx will be dv upon dy times dy upon dx. So this is again very simple. Hassan, do you think we should do this?
Yeah, if your participant want
Okay, so
follow.
let's quickly have a look at this. So what we need is we need to find dv upon dx, and dv upon dx we can always write as oops, is equal to dv upon dy, because what we are given is v as a function of y times, we can select times from here, times dy upon dx, dy upon dx, and this we need to find at x is equal to 0. So we have, if you see dv upon, everyone has access to question, please have a look at that. dv upon dy is 3y squared, right? And y, 3y squared, and value of y squared we can find, it is going to be at x is equal to 0. Is it 4? I think it's 4. And later times dy upon dx, how much will that be? That is going to be this one. Next they put here, so 3 times, it is going to be 3y squared times, just use the part a, so your answer will be, this is equal to 3 times 4 times 3 by 4, that is 9. I think 9 should be the answer, will be 9. If there is any error, that will be calculation error. So because we know dv by dv upon dy will be 3y squared here, and dy upon dx we did in part b. So at x is equal to 0, we can find. So it's a 2 marks question. So I think that's all in this question. So
Yeah, so Jalaj, you did a very smart way of solving the implicit function. Like you have defined two different function. You saw that it is being a quadratic equation. So you define two functions from quadratic equation. So
yeah, I would like to add one thing here.
yeah,
When I saw this and I realized, so I just checked and I did some investigation in most of IB diploma exam questions. These, whenever we have implicit, the question on implicit functions, most of the times we can form a quadratic equation. equation, or some
Yeah,
equation
that
which is
was my next question. Yeah, so thank you for
okay.
answering
So,
that.
or either we can make quadratic, or we can form a friendly form that can be drawn. I'm
So,
talking about paper two. In paper one, I have not seen this. In paper one, usually they mix in implicit questions, but in paper two, yes, it is always a friendly form.
okay, so we can do this. So most of
Yes.
the questions of implicit function has this kind of form.
Yes. If they don't have this form, we have to do it manually. There is no other way.
Okay, so let's move to the next question.
Let's move on. Question number three, four. How we have lots of time. So shall we move on to three? There's a very interesting question here. Number six. Question number six. If you see, so I wanted to do question number. Would like to do question number six first. Is it okay if we
Yeah,
change order,
yes,
sir?
yes, yes. Yeah, definitely.
Okay, so let's move on to question number six. It says that the function f. Do I have Hassan? Can you show this question on the screen, please? Number six. Uh, the function f is defined by fx is equal to 2 ln x plus 1 everything whole divided by x minus 3, where x is between 0 and 3. Find f prime x, that is first derivative, commonly called f dash x. Hence or otherwise, find the coordinates of the points of inflection on the graph of y is equal to fx. Then draw a set of x's showing x and y values between -3 and 3. On these axes, sketch the graph of y is equal to fx. Fx means the graph given in on top, showing clearly any axis intercepts and giving the equation of any asymptotes. And then final D is sketch the graph of inverse function f inverse x, showing clearly any axis intercept and giving the equation of any asymptotes. Hence or otherwise solve this inequality. So this is a long question, and let's do it. So moving on. So let's do it this way. How to do this? See, when you have questions like this, my suggestion would be I love to do that. And if you wish, you can do is to define your function first, because we will be using this function again and again. So what we can do is we can define. Now, this is a new problem. So you can insert a new problem here.
Jalaj, your screen is not shared, so if you can share.
Okay, so let me share this again. I don't know where is my this thing here. It's here. Okay, let me share my screen again. Okay, so since this is a new question, so I'll start with a new problem. Insert and problem. When you insert a problem, then what kind of problem? You can add a note. Note is a good actually application here. Very good. I like note page. So in note you can write anything. You can you can enter and write anything and use it. And if you don't like this, you can go back and delete this. And if you let me show you a little difference here. If you have a calculator page, if you write something which is not mathematical and you enter, it says there is an error. So, and you cannot write notes here unless you go to your menu action and insert command. If you insert command, then you can write something. So to avoid all this confusion, the best way is use notes. So here in this question, the function fx is defined as 2 ln x plus 1 over x minus 3, where x is between 0 and 3. So I'll go to menu and insert a maths box. Then I'll define fx, fx, my function fx, I'm defining as 2 ln x plus 1, and this is a fraction, so I'll put this as 2. Ln is here, and we have a facility of writing, but try using from the template as much as possible. Ln x out of the bracket plus 1, whole thing divided by x minus 3, so x minus 3. Now I can just enter and define this, but there is a domain given that x lies between 0 and 3. So to define the domain, go to the special symbol such that x is between 0 and 3. So 0, again, less than sign is here, and x, you can use from your, if you're using emulator, you can use your keyboard also, but I like to use it from here. This thing, and I'm done. So this is my function. Now the first part of the question reads, find f prime x, that is the first derivative. So first derivative, I think we don't need to do. So part A, we can do it. You can do it yourself. Oops. You know why this error? Because when I inserted this box, I'm still there in mass box. Now I can say part A, I just leave for you all. Part B, draw a set of axes, so hence or otherwise find the coordinates of the point of inflection on the graph of y is equal to fx. Now this is our function. So point of inflection, find the coordinates of point of inflection. The best way to do this is to draw it. And on point of inflection, when we talk of calculus, we talk about the change. Now, when we talk about the change can also change. Means we can find the rate of change, how fast something is changing, how slow something is changing. So the point where the change is either highest or the lowest, that is our point of inflection. So when we talk about the change, we talk about the first derivative. And when we talk about change of change, we talk about the second derivative. So when the change is highest or change is lowest, then the second derivative should be 0. We all know that. So I'll go and draw fx here. This is my fx. Now f is bold means we are using f from the previous page, and this is how it looks. And we have so much of space which is not needed here, so we can make a zoom box around it and see exactly how it looks. Yeah, so that's how it looks. So now we are looking at the point of inflection. Point of inflection means second derivative should be 0. So there are two ways. Either you find the first derivative, then find the second derivative, manually put it equal to 0, find the value of x. Otherwise, what we can do is we can draw the second derivative of this function. How do we do this? We use the template, which is right here. Second derivative, uh, this one, second derivative of fx, and enter. So this is, the red one is second derivative of the blue one. So we are looking at the point where the second derivative is 0. So we are looking at this point. So we have another wonderful tool here, trace. Let's trace the graph. Now your cursor is showing this blue, means we are on the blue one. So you can jump by pressing arrow up or arrow down. From up down you can change, and left right you can move on the graph. So when we move on the graph and trace at this point, it says 0, just mark it and escape, go out of this one. Now at this point, second derivative is 0. Now the question is, if the second derivative is 0, does it really make it a point of inflection, or is there any other condition? Anyone from participant, feel free to drop few lines in the chat box. Is it necessary condition or sufficient condition that if the second derivative is 0, the point has to be point of inflection? Is it the case?
We have one comment like concavity must change.
Sign should remain same. Sign of the the first derivative should remain same, right?
Sign of second differentiation
See,
must
second
change.
derivative is zero and concavity is changing, of course, from positive to negative. So we can say like there are so many checks, either concavity, we can look for the second derivative. And thank you so much, participant. Who replied that?
Brijesh.
Brijesh, thank you so much, Brijesh. So we can use second derivative, we can use first derivative. The sign of first derivative should not change. It should remain either positive to positive or negative to negative. So this here we can see this is a point of inflection. Now, uh, is this actually a point of inflection? This gives you the x coordinate of point of inflection, right? It doesn't give you the point of inflection. So where is point of inflection? It is somewhere on this line, on this blue one. So what we can do is out here, because what is seen on the screen is up to few decimal places. So you can select this x coordinate and you can store this x coordinate as maybe a. Did we use a anywhere in the question? No,
No.
we can use a. So I enter as a. So this is a. Now I would like to mark a point. So I press point P. Now this is in CX2, and if you're not using CX2, then you can get this. There won't be point shortcut in TI Inspire old calculators, but you can go through menu, geometry, and point here, points in line, point and point on. So I can go to point, and I can just draw point here. This one, and I can exit from here, and then this x coordinate I can just write a and enter, so it will automatically go right below this at the same point. So this point where x coordinate is 0.899 and y coordinate is negative 0.374, I think it should be the point of inflection. This
Uh,
is question.
Can we use trace feature, Jalaj, here?
We can use trace feature, but how will we use trace feature here? Because we need to get exact point. So will it stop at the same point? I'm not sure.
Uh,
So if it stops, great. And if it doesn't, I don't know. So 0.899 comma 0.375. So this will be the point of inflection here. Any comment, any question so far?
yeah, Shada ma'am said like storing it as a variable, the value as a, you can just get rid of the rounding error.
Mhm.
So like you have
Yeah,
stored the
exactly.
value
Yeah,
of
that
x.
is why
So
I did. Because sometimes when you take 2 points, like 1, 2, 3 decimal places, it means we are not taking the exact value. So the amount of error may increase, like premature approximation error may increase. That is why the best.
We could have also gone on the main page, the 3.1 calculator page, and found f of a, right?
Yes, ma'am, we can. Yes, exactly. Yeah. So out here we can find f of a. Oops. But in this one, again, I'm in node. So I need to insert a mass box. And when I find f a, this is my answer. But you can also visualize it here. Thanks,
Yeah.
ma'am. Thanks, Shraddha, for
Yeah.
this. And to visualize, we can see it is right here. So you can do both ways. Part C, draw a set of axes showing x and y values between -3 and 3. On these axes, sketch the graph of y is equal to fx, showing clearly any axis intercept and giving the equation of any asymptote. Okay, so we don't need actually this graph here. So if you wish, you can delete this, or you can do is like, if you further work on this page, this will be too crowded. So I would like to open a new page here, new geometry page. Did I open the wrong page? Yes, I think I opened the wrong page here. So a graph page I'm supposed to open. So I'll just fx and enter. Now it says draw a set of axes showing x and y values between -3 and 3. So we need to arrange, adjust these values. There are two ways to do this. Either you go in menu and you can do in the zoom setting. Otherwise you just click here. When you double click, you can change this value. So I'll change it to -3, and I'll do the same thing for other values. 3, this one goes to 3, and down here it goes to -3. So this is your graph of fx from -3 to 3. Now on these axis, sketch the graph of this. Okay, showing clearly any axis intercept and giving the equation of any asymptote. Now, if you see, there is just one intercept here on x-axis. Then it carries on, and it seems there will be an asymptote here, and there will be an asymptote here. Whenever you make a decision on asymptotes or any decision, do not make hasty generalization. Always look for confirmation from 2 3 sources. So when you look at the question reads, it's here, 2 ln x plus 1 over x minus 3. So it seems that x is equal to 3 is going to be your vertical asymptote here, and x cannot be 0 because it is ln x. So when x is equal to 0, you will get a horizontal asymptote at vertical asymptote at x is equal to 0. So you have vertical asymptote at x is equal to 0 and at x is equal to 3. This we can visualize from the given equation. Also, other sources, when we look at the table of the values for this one, so just select it and press Control T. It gives you the table of values. So in table of values, we can see at 0 it is not defined, and at 3 also it is not defined. Then it carries on. So you can either cross it or just press Control 6 to detach this. So we have two asymptotes here. One vertical asymptote is out here at x is equal to 0, and one is here at x is equal to 3. Now read the question again, showing clearly any axis intercept and giving the equation of any asymptote. So you don't need to draw the asymptote, just have to give the equation of asymptote. So first equation of asymptote will be x is equal to 0. Second equation will be x is equal to 3. But you need to mark this point. How to do that? Trace. Graph trace. And when you come here, it says 0, enter. So this is your point here.
I had a question, Jalaj.
Yes,
Do
please.
you advise your students to use the grid? Is there particular do you think there is an advantage in using the grid?
Using what? Sorry?
The axis, the grid. The,
The grid.
yeah. Is there any particular reason?
No, it just appeared
Okay.
actually. There is no
Okay. Okay.
reason.
Yeah. Thank you.
Yeah, I just noticed, yes, there's a grid here. Okay, so showing clearly any x-intercept. So this is part C. So it has one x-intercept and two vertical asymptotes. Any question, any discussion so far? Hassan, did you see if there
No,
is? No?
no.
Lovely. Okay, moving on. Part D is the sketch the graph of y is equal to f inverse x, showing clearly any axis intercept and giving the equation of any asymptotes. So there are different ways to draw inverse function. So first way is you just reflect it in the line y is equal to x. So just draw line y is equal to x and see where it is. This is y is equal to x. So this should be reflected somewhere in this line. When you're doing it in the classroom, when you're teaching in the classroom, you could use this approach. To find the inverse, we interchange x and y. So y is equal to fx will look like x is equal to fy, right? Just enter x is equal to fy and move this text close to any of the axes. Just move it. And once you move it close to x-axis, you say this blue one is your inverse of the black one. And this point was 0.606531 comma 0. So obviously this point will become y comma x. So this will be 0 comma 0.606531. I think this, Hassan, can we use this in the exam mode?
This text feature we cannot use in mode, like relation graphing would not
Yes,
be
we cannot
available here.
use this in exam mode. So what seems to be required is an alternate method. So when you're teaching in the class, when you're showing them that when you draw inverse function, it is like a reflection in the line y is equal to x. It is very quick and easy to visualize. But in the exam, if they cannot use, then there has to be some other method. And if those who attended like one of the workshops by Shraddha and Hassan, you will remember that we have an alternate method. We can do this with the help of NSolver. So let's quickly see how do we do it with the NSolver. So now this is part D, right? We are still in maths 1. Let me come out of this. Part D. Okay, so now inverse of, let me write it down. Inverse of y is equal to fx. What will this be? This will be x is equal to fy. Please stop me if you find there is something not correct. So when we write inverse of y is equal to fx is x is equal to fy. So it means we need to find x values corresponding to each possible y value, because your function will give you possible y values corresponding to each value of x in the domain. And when we talk about the inverse of function, then we talk about the values in the range or codomain, classically back to pre-image or the domain. So it means the inverse function will be same as locus of all the points satisfying, can we say, this equation. If I draw a maths box here, so inverse function will be locus of all the points satisfying this equation. What is this equation? Calculations, go to this one, numerical solve, and solve, and x is equal to fy. So x is equal to fy. Where is f? F is here, a bracket, y. X is equal to fy. And what will be our variable here?
The y would be the variable.
Y will be the variable, because we are finding value of x corresponding to y values, right? So y value will be a variable. So locus of each point. So we actually, if you do this, we are finding all the values of x corresponding to values of y. So we can define this as another function. So I would like to define this as g. So let's say gx is, my gx is defined as this, and I enter. So once I enter, gx is defined. So I go back to my calculator page, and this one was the inverse. I can delete this, or let me not delete this, let it be there. Let's see what happens when we draw gx. So let's draw gx here, enter. Wow. Yeah, we are getting reasonable, very good graph here. So this green one is basically inverse of the black one. And we can use this method in the exam because this is enabled. We can use it comfortably. So sketch the graph of y is equal to f inverse x, showing any axis intercept and giving the equation of any asymptote. So out here, your asymptote will be, horizontal asymptote will be your x-axis, and the line y is equal to 3. And this point will be corresponding to 0.606 comma 0. So if you wish, you can again go and trace it, graph trace. You can quickly see Where is it? Y-intercept, enter, and this is your graph. Hi, yeah, this is the one. Now it is showing some value, negative 5 point times 10 raised to the power of negative 13, which is practically zero actually. So that's how we draw this. Any question, any concern, any discussion so far?
So if anybody have any question, can ask like in the chat. One good going. Okay. One suggestion is, can you please show the questions to then and there, if you can. So
Question.
yeah, Mark has asked like if you can show question as well while doing the
I have to
solutions.
go.
Okay, we'll try to do that, Mark. No issues. Yeah, Jalaj, continue, please.
Wait, hold on. Let me. I'll do this. Give me a sec. I don't know if I can show it like Hassan was showing in two windows, but I can do this. I can change my screen and show. That is the reason we shared this question with you all before the webinar, so that you all have it in front of you. Okay, sorry, I couldn't do that. But I promise in my next presentation, I'll show you question and the solution together on the same screen. Okay, hence or otherwise, last part is solve the inequality. Fx is more than f inverse x. Fx is this blue one, sorry, black one, and this should be more than the green one. So it should lie, the y value should lie above this green one. So it seems it has to be this point onwards. Is it? So from the graph, we can see this point. Um, so what is this point? Actually, not this point. So we need to find point of intersection here actually. So menu, analyze the graph, and let's find point of intersection. Your graph, your first graph is this, and your another graph is this. Why is it asking for corners?
It asks for the corners because you have selected the relation first, then the graph. So this corner point comes. So
Okay,
if anybody see the corner points is coming there. So this is because you have selected relation first.
analyze the graph, intersection. Uh,
Yeah, Jalaj, you have to just define the two corner points and it will give you the solution. It will give you the
okay,
intersection.
let me try this again. Oops. When I intersect, I can do these two and intersection. So this is my point of intersection. It is again like too crowded, but we have to remember this 0.372 is the point of intersection. So this point downward for all values of x, the graph of the function is always above the graph of its inverse, or its y value is more than its y value of its inverse. So your answer will be x is less than 0.372. So this is all in question number 6. Anything, any concern, any discussion, or maybe a better method, any feedback, anyone?
It should be greater than 0. Should that be mentioned, that it lies between 0 and 0.7372?
Yes, good point. Thank you so much for doing this, sharing this. Now, in if you see in the graph, in the question, original question, fx was fx was refined between 0 and 3, right? And in this question, your answer is coming less than 0.372, but it has to be more than 0. So it will lie between 0 and 0.372. Thank you so much for that.
I think this visual just makes it reminds the student, or in this case us, that we've got to, because it's really visual, so you can see that you can be reminded. that the
Yeah.
function is defined between 0 and 3.
Yeah. This function, there is no point like beyond 0. Great. Thank you. So let's move on. And Hassan, would you like to do something? I
Yeah,
mean, would you like to solve some question?
I
Uh,
would like to
so
solve.
many questions you can
Yeah,
pick.
so many questions. So I would like to solve this question number 4, where we have given a velocity equation and we have to find certain points given in the question. So before I do that, I just wanted to show one of the feature, like Jalaj also highlighted, like he doesn't know about that. So here in my emulator, so this is the teacher software. So here I have two screens, so I can work simultaneously on both the screens,
Can
or
you
even
show us how to do this?
yeah, I'm just going to show that to everyone. Like uh, originally you have only one screen, okay, and if you have opened multiple uh, windows, the documents, you have something in the bit below, you can see like two documents I have opened. So if you open another document, let's say, so if you have opened one more document, so how do I do it? Yeah, so here comes the third one. Okay. So I have now three documents open simultaneously. So now what I can do, let me just remove this document number 1. Or what I can do, I can just right click on the document name and you can see the two grouping option is coming. Like you can horizontally group or you can vertically group. Okay. Can you, Jalis, can you hear me?
Yep, that's
Okay.
so cool.
Yeah. So you can group vertically and horizontally. So if I click new vertical group, so it will group both the documents. Okay. And I can adjust my window accordingly and zoom settings will be adjusted accordingly. Okay. So you can simultaneously work on both the screens, like you can show question in one screen, you can solve on the second screen. Also, I can do question. Yeah, this is a very awesome presentation strategy. So what I can do, I can just right click and I can say, okay, now this time I want a horizontal grouping. So you can even do the horizontal grouping and you can change the window up and down and you can just uh, you can choose from either of the two, like what feature you want, and you can say like previous. Here other options are also there, like change tab group orientation, like it will give you the vertical. If you say no, I want to change tab group orientation, you just select this and it will become a vertical. Okay, so this is how I have done grouping. Okay, so I group two different documents. You can group three different
Wonderful.
documents.
Love
And
it. Thank you so much.
okay, so let's move to the question number 4. Let me just share. Yeah, here the question number 4 is, so here a body moves in a straight line such that its velocity v after t seconds is given by a equation. Okay, from 0 to 60, the time period is given as from 0 to 60 seconds. Okay, so t is in seconds and velocity is in meter per second. So the following graph, so following diagram, so one diagram is also shown here, says point A is a local maximum and point B is a local minimum. So it has given a diagram which says like point A is a local maximum and B is a local minimum. So it's a very straightforward question, not much to do. It asks you determine the coordinates of point A and the coordinates of point B. Hence, write down the maximum speed of the body, not the velocity. It asks the maximum speed of the body. The body first comes to the rest at time t equals to t1. This is the C part. He wants us to find the value of t1. The distance traveled between 0 to t1. It asks the distance traveled from 0 to t1 and then the acceleration when t equals to t1. Okay, so it also asks you the acceleration when t equals to t1. And uh, by the way, this is the velocity graph. Okay, so velocity function is given and we need to find the acceleration, and in the last part we need to find the distance travel in the first 30 seconds. So let us do this question by using the features of our calculator, and let's see how calculus is also related to these kind of questions, these physics kind of questions. So what I'll do, I'll define a velocity function with respect to t. So what I'll do, okay, I'll say vt. Okay, so vt is my velocity function with respect to time, and I'll store it as this function. Okay, should I do this?
Hassan,
Please
Hassan,
share
I
the
think the
screen.
calculator is not visible.
Oh, I'm so sorry. I'm so sorry. Okay. I didn't write much. So yeah, now the calculator will be visible for everyone. So what I'll do, I'll store a velocity function here with respect to time, and I'll say, okay, so this is two times sine of t over 10 plus pi over, let me just see in the figure, pi over 5. So I'll say, okay, sine, I'll say sine, oops, yeah. So I need this colon equal to sign to define. And then I'll get this and I'll say, okay, t over, so I'll do it like t over 10 plus, again a fraction template, and I'll say, okay, pi. This time I'll write pi. Pi is a shortcut for pi. If you don't want to go into pi key, pi is very easy to write as well, because p and you can see above I, so pi both are there uh, uh, above each other, like p and then above it I is given. So pi over 5 times cosec, oops, move this, cosec t over 10 t over 30, sorry, plus pi over 4. Okay, so this is the equation given, but the time is defined only from 0 to 60. So we create a constraint here saying such that t should be lie between 0 to 60. So t should be lie between 0 to 60. So I'm doing this is a shortcut if you are using your emulator. So these are the shortcut you can write less than equal to for less than equal to symbol. So if you press enter, it converts into the actual symbol of less than equal to or greater than equal to. So you can see that. So my velocity diagram, velocity function has been defined. So let me just draw a graph of it. So I'll add a new page. I'll say, okay, graph v of x. Okay, so this is my graph. Jalaj, my settings are in radian. So is it okay to have a settings on in radian, not in a degree?
Which one? Sorry.
See, I have used a trigonometric functions here, and my
Uh-huh.
settings in radian. So
Yes,
is it
I think whenever we are in calculus, make sure that you are working in radian.
absolutely? So I'll just change my window setting to 60, and I'll say, okay, from 0 to 60, so I can see 0 to 60 graph. Now I can find the value of a, I can find the value of b. And good point from Jalaj, like whenever you are doing calculus, your setting should be in radian, and by default, yes. The point is, when you go into a press to test mode, you can you can change what default setting you want. You want degree or you want radian in IB. Okay, and by the way, later you can change to degree or radian. So now if I go to trace, I can trace the graph. Trace feature is very wonderful. Okay, you can get everything in one shot, like maximum, you can get minimum in one shot, like first question done by using trace feature. So this is a wonderful feature like trace. You can get the results very quickly. Okay, you don't have to go again and again in the menu and go to analyze graph and the intersection or the maxima or the minimum. And then in the second, it asks write down the maximum speed of the body. Okay, so it asks the speed of the body. So now this is the velocity graph. Can anyone tell what would be the maximum speed over the period from 0 to 60 seconds? Anyone?
Yes. Shraddha mentioned negative 2.45. Yes, it may look negative, but remember that negative is just the direction here. So
Absolutely. So
it
negative is the direction. So it suddenly changes its direction from positive to negative, like
so
from
2.45.
going forward, or it changes direction just the opposite. So that is why it says minus 2.45, but the speed would be maximum at minus 2.45. So this would be the maximum speed at 43.4 seconds. Okay, that you can also indicate, like at 43.4 seconds, the speed was maximum. Hence, write down this maximum speed of the body. We already know that is 2.45. And the C part is the body first comes to the rest at t equals to t1. So body is at rest when the velocity is 0. So we can find this point of intersection with the x-axis, and we can say, okay, again we'll use the feature of trace. Okay, so we'll go to that point, it automatically snaps, hit enter, and you get the value as 21.1 for t. So at t equals to 21.1 seconds, the velocity was 0. The body was at rest. Okay, it wasn't moving. So
And Hassan,
yeah,
sorry, a good practice could be when we trace, in the first trace, we can mark all important points like all intercept, x-intercept, y-intercept, any turning point. So just mark them and keep it. You usually use it somewhere in the question.
absolutely. So if you are using trace feature, you just mark all the important points. Okay, so it's a great practice. Like at once you get all the points, and somewhere in some point in a question you will be using those important points. Okay, so we got the point. We got the time t1 25.1 seconds, where the velocity was 0, the body was at rest. So what I'll do, it says that t is t1. Okay, so what I'll do, I'll copy the Jalaj feature and I'll store this time. Okay, I'll say, okay, I'll store this variable as t1, so that I don't have to use again and again 25.1 everywhere. Okay, so now my time where the velocity was 0 and the body was at rest is 25.1 seconds. So I can add a new calculator page. I can say, okay, t1, it is, see, Shada ma'am said, like, you can avoid the error in like, yeah, Shada ma'am said something about decimal points
Yeah,
error.
that premature approximation
Yeah,
error.
so you can avoid that by storing. So here you can see 25.1, but in actual the t1 is not 25.1, it is 13274. Okay, so we can avoid just by storing. So is there any question? So can we have
Okay, there's one more x-intercept. Why are we not taking that intercept? Because the question says the body first comes to rest at time t is equal to t1. So we are
exactly
talking about the first time when
the
it
first
comes.
instance when the body comes at rest?
Yeah.
Yeah, I should have mentioned that. Yes, the body first comes at rest. Okay. Yeah. So now it says in the D part, says that find the distance traveled between t equals to 0 to t equals to t1. So Jalaj, this is the velocity function.
Mhm.
It is not the distance function, but it's a not a speed function, but it's a velocity function. So how would we find the distance travel? Do
See,
we have to
between
just
0 and t1, there is no turning point.
so we
So
don't
it's
have any turning
just
point, so we just
integrate.
have to integrate?
Yeah, but a good practice is always integrate the absolute function, absolute
Absolute
of the
function.
function.
So this there is a good
Here,
practice.
between 0 and t1, there is no turning points. So either you use absolute or directly use the function, you'll get the same answer.
Absolutely. So what we'll do, we'll use the good practice. We'll say, okay, from 0 to T1. So we don't have to write 25.1 and something, something, so on. We just have to write T1 and we'll say, okay, velocity with respect to T, with respect to T. Okay. So it should give us the result. But I haven't used the absolute function. I can use that. What I can do, I can just, before writing VT, I can go to my math template, and in the math template, I can see the first row, last column is the modulus. Okay, I can select that and I can write V of T.
Or we can just write ABS and in the bracket VT.
Okay, let me just try that also. So first, let me just do this. Hit enter, gives you the result. So Jalas said, rather than using the template, you can even write A, B, S for absolute. So as soon as I write A, it's at italic, B, italic. As soon as I press S, it comes normal font. Okay, so that means there is a function called ABS inside this calculator somewhere. Okay, you won't get that ABS anywhere in the menu, but you can get it in the catalog. Okay, if you go A, you get the first thing as ABS, absolute function, and inside this absolute you can write V of T. Hit enter, you get the result. Okay, so this is a cool way. Yeah, Jala, thank you for telling me like ABS also there, also available, and it's also available in test to test mode, no issues.
Yeah.
Then it's asked the acceleration when T equals to T1. So Jalaj, how do we do that? Like acceleration is what?
Change. Change
Change.
means calculus. Instantaneous
Calculus.
change means use derivative.
Yes. So here comes a change. Here comes a change in the velocity. So what we'll do, we'll say, okay, change in the velocity with respect to time, with respect to time, and at a particular. So, Jalaj, is it asking for the instantaneous acceleration?
Yes, at x is equal to the question. If we see what is the question,
Question says the acceleration when t equals
when
to
t
t.
is equal to t1, so at a particular point. So
So
we need
it's an
to give the
instantaneous.
condition here
So we'll say, okay, such that t
such
equals
that t is
t1.
equal to t1.
Hit enter, you get the negative acceleration. So why we have got the negative acceleration, Jalaj, at t equals to t1?
The speed is reducing,
The
decreasing.
speed was reducing. Absolutely. So this is how you can do the calculus
Yeah.
in this question. Yeah, Shadam, I want to say something.
No, I said this is an ideal question to use to test, for a formative kind of a thing to test students' understanding of integration and differentiation and the use of GDC skills, conceptual understanding and stuff. I think this is an ideal question where student needs to go backward, forward, and effective use of time.
Yeah,
Yeah.
it is brilliant. Yeah.
So this feature of defining or storing a coordinate is very important here. You can avoid the errors.
Yeah.
How I did that, if anyone didn't see that, let me just unlink this. So what I did is I went on the coordinate, I selected this coordinate. One way is, let me show you both the ways. Okay. So one way, just hover on the text. When it says text, just right click. Right click is control menu, and you'll get the option number 5, store. Just click option number 5 and store it as T1. Hit enter, it gets stored. Okay, so second way of storing this is by just click and select. Now it is grayed out, so it is selected. So now on the keypad you can see a var key. Okay, just press this var key. You'll get a window asking you to store the variable. Okay, you can choose option number 1 and say okay, T1. Hit enter and it gets stored. So there are two ways to storing the coordinate.
And in the exam, sometimes they ask in the question mark scheme, they say CAO, correct answers only. So even if you're like wrong by one decimal place, or say tenth, 1/10 or 100th, if the answer is not exact, you may lose marks. So before the final answer, it is always advisable to use the exact value. So
And
this will help you to avoid
and
premature.
and student can check by entering the variable in the calculator application. Like they can put the value t1 and they can check what are the decimals coming in the what is the uh, full uh,
Listen, out of curiosity, instead of
yeah.
writing T1, can we see what happens if you write 25.1? Just out of curiosity.
Okay, we
Yeah.
can
How,
check.
yeah.
No issues, we
How
can
much
check.
it
So
differs.
what I'll do, I'll just store this t1 itself as 25.1. Okay, so now I'll recalculate everything. Okay, so I'll say, okay, the distance, it gives you 40.98335. Before it was giving you 40.98346. Okay,
Okay. Yeah, not much of a difference
not
where
much of a difference.
Yeah.
But if we calculate acceleration, it gives you uh, yeah, not much of a difference.
After 3, 4 decimal
Four
places.
decimal places, it's almost same. So yeah, that also you can do. Okay, so this was the question number 4. So I think we have done 4, 5 questions, Jalaj.
I think there's one more part, Hassan, here.
Oh, one more part.
Yeah.
Oops, I missed that. No issues. So the last part is find the distance traveled in first 30 seconds.
Yeah. Can you share a
So
screen?
let me share. So in the last part, it says find the distance traveled in the first 30 seconds. So it would be very similar to the option, the question number, the part 4 or D, where it asks you from 0 to T1. Now it's asks you from 0 to 30. But when we do from 0 to 30, the graph changes from positive to negative. So here, this absolute value comes in handy, and we can say like not T1, we want 30. Hit enter and you get the result.
yeah.
Wonderful.
Even we can show the students like what would be the graph when we say absolute values. So we can go to the template and we say, okay, v of x, what would be? So it would be like this. And up to 30, we can even find the area bounded. Can we find integral for this graph from lower bound 0 to upper bound 30? So it gives you the value 43.3 within a graph itself. Okay,
Wonderful.
so this is also you can do to find the distance traveled.
That's great.
So is there any question, any discussion?
Now, Hassan, we have around
20 minutes. So do you want to
20
do any
minutes,
question, Jalaj?
17 minutes actually.
Ah,
So should we do another question, or shall we open this for discussion, questions? Because I don't think in next 15 minutes, 16 minutes, we'll be able to complete any more.
yeah, we won't.
So you can unmute participant, those who wish to discuss or give any feedback and discussion. Uh, what do you say?
Yeah. So now it's an open forum. You can even share your thoughts, comments.
Jalaj, can I ask one question?
Please go ahead.
Yeah, sir, I think just wanted to go to the inflation question. I just wanted to see that quick shortcut one more time. How did we just move from the double derivative function to the main function and get that point on the graph?
Okay, sure. Hassan, do you mind? Okay, let me share my screen.
Yeah, Jalaj, you can share.
One moment. Okay. Oh, I was trying this one. This was the question. Was it the question? No. This was the question, right?
Yeah, just wanted to know how do we move from that double derivative graph quickly to the mean graph.
Okay,
Wait,
so
he's asking the trace, how you jump to the trace from the arrow, top arrow.
no, but I think he meant the point function. So this point trace, we can, th we are here, 0. Okay, so this was the point. So is your question, how do we get the point corresponding to this on the drawing?
Exactly. Yeah, exactly that.
So what we do is we go to a point, just draw a point. So point, if you're using CX, you can just press P. When you press P, this point option will come, point or point by coordinate. If you're using non-CX, then you can go to menu and geometry, point and lines, and point on. So, or point by coordinate, point on or point by coordinate. So I'll go with point on, and this I can get from here also by directly pressing P. So point, then you can mark point anywhere on this blue graph. So once you do this, you see this point has a coordinate, right? But we would like to have a point whose x coordinate is 0.899051. So what we do is we select it, right click, you store it as some variable. Maybe I'll select it as say x1 and enter. So now out here, I'll go click and write x1. This one, that double click and write x1 and enter. So this is the point, what we are looking at.
Thanks. Understood.
You're welcome.
So Mark, you want to add something? You want to say?
So if I speak, are you able to hear? Hello.
Yeah, hello.
Yeah, can you hear?
Yeah, we can hear you. Yeah.
Okay. Yeah, it is a nice session. There is no doubt in that. Unfortunately, we could not join because we had a class school till 4 o'clock, and again we were having a departmental meeting. So I have joined a bit late, but a lot of new things. Though I'm using the same TI Inspire for a longer time, there were new options which was quite interesting. Really, it is more beneficial. Uh, my personal feeling is because my school is opened last week and this week, last Saturday and this Saturday. The class last Saturday it went till 5:30, unable to join. This Saturday up to 4. Then after that some more continuous discussion. That's why again we were not able to join. So that was a bit uneasy things. If you could share the video link, class link, definitely I will go through. I cannot request you to conduct once again. That is not fair.
Definitely, we will share the
Please
recording.
share the video recording. Yes, it's good. Yeah, I was the one asking that. The questions also then and there, if you share it, it's good. Again, your reply came with already you had set a questions, and we could have gone through. Yeah, that we could have done that. I missed it. I too had doubt that whether I'll be able to join today or not, but somehow we got time. And whatever the time I have utilized many new things. Nice, really, really nice.
So recording will be shared with every participant. No problem.
Yes, yes. Even the previous recordings, will you be able to? Though we didn't join.
So 91949. If you can tell your name, that would be great.
Because straight away, what we will do, we will send to our students. Our school is we are using only TI Inspire for the past 7-8 years. And ultimately, we can send that link, and below to that, we will be mentioning that these are the areas were discussed by the team of TI Inspire. They may not look at it immediately. Once that chapter comes on, they will go through. That's what we will do. Yeah, if possible, you send it. Otherwise, it's okay.
Okay, thank you, Mr. Mark.
And always, I used to go through somewhere if I have doubt. Now I used to go through your YouTube, just type and then get it. But these kind of things, live one is still better, much better. Yes, good. Go ahead, please. Thank you. Thanks a lot for
Thank
this.
you.
kind
Thank
of
you, Mr.
session.
Mark. Thank you.
Welcome.
Anyone else has to say something?
I have a question.
Yeah, Girish sir, go on.
Hassan sir, it would be a IGCSE question, not IB question. What all kind of graph can we draw using this TI Inspire?
Everything.
Everything, histogram.
Everything.
That you can think of, we can do this.
Yeah, histogram also possible, but we should learn it. We need to
Okay.
see, instead of asking them, I'm telling them how to draw histogram by using TI Inspire. Ask in YouTube. Someone might have explained. Hopefully, most of
Okay.
the things that I'm getting like that. If
Okay.
necessary, I do that.
Okay. Okay.
But for TA, but for IGCSE level, this histogram is generally expected the manual work up to my knowledge.
Yeah. It is manually only, but I would like to know whether we are able to do all kind of graphs. I know as it is a graphical calculator, we should be able to do.
There is
Only
definitely there are possibilities. Even
Yeah.
cumulative frequency curve, whether there is or not, I have a doubt in it.
Okay.
Cumulative frequency curve, there might be,
Okay.
but we need to look back with the YouTube.
Okay. Okay. So
This is what it
I'll
was
look-
told in my workshop, somewhere TI Inspire workshop, which was held in Pune 2.5 years before. Anything, just you type it. Someone from their team, they have done and uploaded. It will pop up. Yeah.
in the
I mean,
YouTube.
in the YouTube.
Okay. I will look for. Thank you, Mark.
Thanks for the idea. Maybe I'll try to do something like that. But I learned something new today. That documents, that is fantastic. How to share that.
Yeah, that was a
I
real.
like the horizontal. That is fantastic.
Oh yeah, that was great.
For the regular, this might be the screen size is smaller. If the same thing, if you are displaying on the classroom, still it will be much better. No, one side the question, the other side the working part. It will be like movie. It will be very nice to see.
Yes.
Yeah, big screen.
Mark sir, what you can do, you can drag your keypad and make it small, and your screen size will become bigger.
Is it like what once again?
Let me just share and show you. Like you
Yes,
you
please.
can drag your keypad, like you can increase your keypad size, and the windows, the main working side will become smaller. But you can just
Okay.
resize your keypad, and that screen.
That's good. That's good. Again.
So I think thank you all for joining. I think one of the comment I seen, like they have another meeting. So
I have a question. Not related to this. Am I audible, Jalaj?
Yes, is it from me?
Hassan, am I audible?
yeah,
Yeah.
you are audible, yes.
Here you are.
Good. Anyone else has any problem with my audio?
No, you are clear and loud and clear.
Okay, thank you. I just wanted to confirm. Hassan, you're recording this, right?
Yeah, I'm recording.
Good.
Okay, thank you so much, everyone.
Thank you, Jalaj. Thank you all the panelists. Thank you all the participants for joining the today's session. So
Thank you, Anjan.
we'll inform you for the next session by mail. So
Thank you, everyone.
thank you, Mark.
Thank
Thank you, Anjan
Welcome.
sir.
Yeah.
Thank you. Thank you, Vijay sir. Thank you, Mary.
Thank you, Hassan, and thank
How
you,
many-
Douglas.
How many
Thank you.
participants today?
Good learning.
Are we waiting here or are we doing another meeting later?